Welcome to qnawire.
Alright guys, we're going to be doing problem 42 of chapter 9 in Chemistry Central Science. So they want us to predict whether each of the following molecules are polar or nonpolar. So let's start with CCl4. So this is a tetrahedral structure. You have dipole moments going from the carbon and going to your chlorine over here. Now since tetrahedral structure, there's going to be dipole moments on each of these bonds. Let me show you. And because we have a tetrahedral structure, the dipole moments are going to cancel out. So this is going to be a nonpolar molecule. So NH3, we have 3 NH bonds, and then we have a lone pair here. If there is no lone pair, we have a trigonal planar, and each of the NH bonds would have, and the net dipole moment for trigonal planar, if all the bonds are equivalent, that's going to be 0. However, because we have a lone pair here, we have trigonal pyramidal. So our dipole moments are not going to cancel out. So this is going to be a polar molecule. Now, for SF4, we have 5 electron domains. So we have a trigonal bipyramidal electron domain geometry. So now we have 4 bonds and then 1 lone pair. So that's going to be a seesaw conformation. So seesaw conformations, our dipole moments are not going to cancel out. So this one is going to be polar. You can see that's not going to cancel out by looking at your Vesper geometry chart. You can see that the seesaw structure, you have one fluorine above and one below, and you also have 2 on. And the ones that are in the plane, and the 2 that are going to be in the plane with respect to one another, those are not going to face in opposite directions. So that is going to give you a net dipole moment. Now, for our xenon tetrafluoride, we have 6 electron domains. So its electron domain geometry is octahedral. So since we have 2 lone pairs and 4 atoms surrounding it, we have a square planar electron geometry. So all the dipole moments are going to cancel. So these 4 fluorines right here, these are going to be the 4 corners of your square. So they're each going to point dipoles both towards the fluorine. So this one's going to cancel out with this one, and this one's going to cancel out with this one. So this is going to be a nonpolar molecule. Now for this one, CH3Br, that means so this is a tetrahedral structure, just like CCl4. However, you'll notice that not all the bonds are equivalent. You're going to have a dipole moment in this direction, and there's nothing to cancel it out. So we're going to have a net dipole moment, so this one's going to be polar.